Last lesson, we went through many of the important properties that we use in math, the commutative property and associative property and identity property and inverse property. We talked about why we needed those things. And today, lesson 14a, day number 1 of another extremely important property in math, the distributive property. So today, we will learn to simplify expressions using the distributive property. We're going to learn how to correctly state distributive property problems, and then our why am I learning this? Distributive property basically says that A times the quantity B plus C is equal to A times B plus A times C. Or A times the quantity B minus C is equal to A times B times A, or minus A times C. And usually the question is, well, where is this coming from? Well, basically what we're doing is we're multiplying this times this. That's where we got the A times B. And then we're also multiplying the A times the C. That's where we got that. And same thing right here. This times this, and then this times this. That's where all of that comes from. So if we were to do it in terms of numbers, we could solve this problem using the order of operations like this, or we could use the distributive property. So using the distributive property, we're going to go 3 times 4 plus 3 times 5. That's where this comes from right here. And then 3 times 4 is 12, and 3 times 5 is 15, and 12 plus 15 is 27. So you can see that we get the same thing. So some of you might be thinking, well, why don't I just use the order of operations instead? Well, the reason is very simple. A lot of times when we get into more algebraic stuff, we have to use the distributive property to get rid of parentheses when we have variables involved. So that's exactly what we would do right here. We would multiply 3 times x and then 3 times 2. And so we would get 3x plus 6. All right, so let's do a little bit of practice here. Here is number 1. We're going to do the first couple together, and we'll learn how to read them correctly. And then we'll have you try some on your own. So the first thing we want to do here is we want to multiply the outside number times the very first part, the x there. So we have 5 times x, and make sure you take good notes here. And this is an addition problem, so plus, and then we're going to multiply the outside number times the second part, and that's usually the part that people forget. 5 times 3. Well, 5 times x is 5x. And 5 times 3 is 15. And so 5 times the quantity x plus 3 is equal to 5x plus 15. So are there any questions on how we came up with 5x plus 15? It should be very simple. Once again, 5 times x and then 5 times 3. 5x plus 15. Now what we're going to find out in a few days is we can't do anything else with this 5x plus 15. That's why it stays like that. So one more time. 5 times the quantity, and this is one of the things we're going to work on today, is how to state this part right here. That's 5 times the quantity. Every time we have parentheses around something, that's the quantity. So 5 times the quantity of x plus 3. And that is equal to 5x plus 15. 5 times the quantity, x plus 3 is equal to 5x plus 15. All right, everybody try number 2. Okay, give it a shot.
6y plus
Wait. Not the answer, the entire process. Remember, number 1 was 5 times the quantity of x plus 3. That's this part. That's the problem. 5 times the quantity of x plus 3 is equal to 5x plus 15. And that's what I meant by our language objective, or this part right here, that we're going to learn how to read distributive property problems correctly. Okay, you want to try it again? All right, who has it? All right, well then say it along with me. 6 times the quantity of y plus 7. So that's the original problem. 6 times the quantity of y plus 7. All right? So Ella, what does that equal then?
6 6y plus 42.
Okay, so now say the whole thing.
6 times the quantity plus y plus 7 equals 6y plus 42.
All right, there we go. So 6 times the quantity of y plus 7 is equal to 6y plus 42, and that's the reason why right there. All right, everybody try number 3 and number 4. All right, Daniela, what'd you get for number 3?
3 times the quantity m minus 8 is equal to 3m minus 25.
Very good. 3 times the quantity of m minus 8 is equal to 3m because of the 3 times m, and then minus 24 because of the 3 times 8. So 3 times the quantity of m minus 8 is equal to 3m minus 24. Leo, number 4.
4 times the quantity of 3 minus y is equal to 12 minus y.
Okay, so here's what Leo said. See if you can figure out where he made his mistake. He said 4 times the quantity of 3 minus y is equal to 12 minus y. This is the most common mistake. Yes?
It's supposed to be 4 times 3 minus the quantity, which is 4 times 12 minus the quantity.
Say that again. Say that again.
4 times 3 minus the quantity, which is 4 times 12 minus the quantity.
Okay, I'm not quite sure what you're saying there. All I'm asking for right now is where the mistake was made. Because here is, he read the 4 times the quantity 3 minus y correctly. But then this is what he said it was. Right there, 12 minus y. That's not correct. What did he forget to do?
He forgot to say 12 minus 4 times y.
Yes, he forgot to multiply the 4 times the y. And every person that I saw, or not every person, but pretty much every person who forgot to or didn't draw arrows like that, and these are supposed to be arrows, they're just sloppy arrows, but you have to multiply that times that and then the 4 times the y. So you need to make sure that you're multiplying both parts by that outside number. 4 times 3 and also 4 times y. So that should be 12 minus 4y. All right, quickly, do number 5 and number 6, please. As you're going through 5 and 6, the distributive property is one of those things that we're going to be doing a lot as we get into equation solving. So it is very important that you do this accurately. Extremely important. All right, number 5, 10 times the quantity, and I heard a much better attempt at reading them correctly this time around when we were shoulder partnering. But the number 5, 10 times the quantity of x plus 7 is equal to 10x plus 70, because we have 10 times x and also 10 times 7, and so there it is. Number 6, same idea. 4 times the quantity of k minus 2 is equal to 4k minus 8, because we have 4 times k and also 4 times 2. Do not forget to multiply the outside number by the second part. That is the most common mistake. So at this point, I think we would all agree that this is pretty easy. The only other issue, if you look in your notes at 7 through 12, is that, number 1, sometimes that coefficient, and we'll get into that on another day, but this number on the outside is a coefficient. Sometimes it is second instead of first. So we've got to talk about how to deal with that. And then also sometimes the coefficient on the outside is a negative number. But since we're all pros at multiplying negative numbers now, it should be easy. So let's take a look at number 7. Here's my first advice. Some of you would have no problem trying this problem the way it's written. But others are probably already a little confused because the coefficient is not in front, it's out back now. However, there's a very important math property that says it's okay to write it like this. We just talked about that property in the last lesson. Anybody have any idea which property tells us that it's okay to do that? It's the commutative property. We're flip-flopping things around the multiplication symbol because this is a multiplication problem. And so my advice to most of you, that when that number is written second like it is, that the first thing you should do is rewrite it to make it look like this. Because if you agree with me that all of those first 6 problems were easy, then you will agree with me that these problems are easy as well if we rewrite them first. So that's my advice to you. All right, everybody go ahead and finish this problem. So once again, it is the commutative property that allows us to be able to do that. So 4 times the quantity of 3x plus 5 is equal to 12x plus 20. When I walked around, that's what I saw from pretty much everybody. And it is the commutative property that allows us to do that. All right, let's take a look at number 8. Let's do the same thing. Let's use the commutative property to rewrite this thing first. And this is what you should do every single time that number is written out back. So let's rewrite it. Negative 2 times the quantity, 4n plus 7. So now this is our first problem where we have to deal with the coefficient out front being negative. So let's do this one together. What is this times that? Negative 8n. The only difference is now we have a negative number times a positive number. So we have negative 8n. Now, what is that number times that number?
Negative 14.
Negative 14. So you have 2 choices here. So listen carefully. You can either write plus negative 14, or you could write your answer like this. Now, why are those the same thing? And this is something we have talked about over and over and over again, just not in this context. Why are these 2 things the same thing? Because we added the opposite. Watch. If I add the opposite, look at what I have. So once again, it doesn't matter whether you write this problem like this or like this. It does not matter. They mean the same thing. They are equivalent to each other. Okay? All right, everybody try number 9 and number 10, please. All right, let's take a look at both of these 2. Number 9 is easy, but it's tricky. And when I walked around and I looked, nobody had a problem with that part. That's obviously negative 30y. But here's what I saw. I saw some of you write this times this as this. And then I saw others of you write your answer like this instead. Quickly turn to your shoulder partner and decide which one of those 2 is correct. I'll give you about 20 seconds. All right, bring it back up here, please. Anybody have any idea which one is correct? They're both correct. Much like, which problem was that? Number 8, much like number 8. Because watch, if I add the opposite in the top one, look at what I have. The same thing. Adding the opposite is how we've been utilizing this little tool of turning a subtraction problem into an addition problem. So they're both correct, but let me tell you which one is the preferred way of writing it. This is the preferred way of writing it. So can you make a little note in your notes that that's really the way that we like to see it? Even though both of those things are equivalent to each other, that's really the way that we like to see it. right, and then number 10 should look like this. Number 10 is 5 times the quantity of 4h minus 9. Of course, I would have rewritten it, putting the 5 out front, and that would give us 20h minus 45. All right, let's finish this idea of the distributive property up. Do number 11 and number 12, please, and then we will compare with our shoulder partner. All right, first thing I would do in number 11 is I would move the negative 3 out front. I'm seeing most of you do that, which is good. What I'm not seeing enough of is enough drawing the numbers that you're multiplying together. Trust me on this, right, Michael? Trust me, you're much less likely to make a mistake if you do that. It's the same thing that I've been, as I go through these with you. What is that times that?
Negative 18.
What is that times that?
Negative 3.
Subtraction, because it is subtraction. And then we have this. That is not the preferred way of writing that, but that technically is equivalent to what the right answer is. The right answer should really, that's the preferred way of writing it. Negative 18 plus 3m. So negative 3 times the quantity of 6 minus m is equal to negative 18 plus 3m. Any questions with number 11? All right, and then number 12, the number is already out front. That's good. I'm going to multiply that times that. What is negative 4 times 6y? Say it, please.
Negative 24.
Negative 24? Y. Don't forget the y. And then what is negative 4 times 7?
Negative 28.
So that's one way of writing it. The preferred way is actually negative 24y minus 28. But those two things are really equivalent to each other. All right, so let me finish that problem up. And I have a question for you. What is another reason for using the distributive property? Well, it's something we dealt with at the very beginning of this lesson, and we're going to go into more detail as we finish the distributive property problem or property idea up. But much like associative property and commutative property, it helps us with mental math, and we're going to see that tomorrow. All right, quickly turn to your shoulder partner. What did you learn today? The twos start the conversation.